Hello everyone, I'm Sara Fiori and I recently graduated from Politecnico di Milano with a master's degree in computer science and engineering. Today I will present an intermediate language for acceptable representations in the field of digital storytelling for people with intellectual disabilities. What we discover from the literature is how much important and effective storytelling can be for people with intellectual disabilities. But when looking at the field application to create a simple animated story or life event, we can note that such software tends to be too complex or not enough specific for the needs. For example, Movie Maker and PowerPoint allow to create sequences or videos, moving object and text, but they are lacking the possibility to abstract and personalize the main concept useful for the description of a story. While software for stories creations have such features, but they are too specific, like Pixton, where the user can create only static comics, or too generic and complex, like Scratch, where the user can create complex animations, or even games. Therefore, with this work, we want to address such gap by providing tools to simplify the process to build an application for the creation of animated story or sequence of images. Because we understand that a one-size-fits-all solution is not what is needed in this field, we design an intermediate language that abstracts the main concepts useful for the description of a story, being flexible and independent from both the specific application user interface and the execution platform. To validate our approach, we also applied it to the design and implementation of an application for digital storytelling that is intuitive and easy to use. The application allows to create and animate stories or real-life events using your own imagination and your own voice, and to share or rewatch them at any time. This can be useful for different kinds of use cases, like rehabilitation or playing times for people with intellectual disabilities or children. This application was tested on the field thanks to the collaboration with educators, volunteers, and people with intellectual disabilities from two associations, one based in Milan and one based in Como. Now let's move to the description of the approach. In our case, we have as a search language the animations and story described in a customized representation that in general are graphical languages. We translate the source language in the intermediate language, and then from intermediate language in the target language. The target language is an executable representation that makes the stories or animations executable. We can say that intermediate language has the role of an abstraction layer that allows to adapt to new or changed needs more easily, both from a requirement storytelling perspective and from a technological one. Following this approach, we can change only the left side of the translation if we want to add new or change features to the source language, or if we want to adapt it to a specific user need. In the same way, we can change only the right side of the translation. For example, if you want to change the target language, or if you want, as a result of the translation, a file executable in different platform. The possibility given by this approach to change the source language in an easier way is very useful in the field of education or rehabilitation for people with intellectual disabilities, because, as we know, they need a lot of flexibility, and each user has a different specific need. So we created an intermediate language that makes possible the abstraction of the concepts useful for the description of stories or image sequences. We try to make it simple and intuitive to use, suggesting also a graphical representation for the programmers. We also define it with a formal syntax and semantics, and we want it to be flexible and easily adaptable to future expansions. The main idea components of the intermediate language were designed taking inspiration from business process modeling notation and Scratch. Now we want to briefly describe the main components of intermediate language using a suggested graphical representation. This is what the programmer used to interact better with intermediate language while creating a new app or translating the image sequences to a new executable language. In the image, we can see an example of the use of intermediate language describing a simple animation process. Firstly, we can see pools and lanes highlighted in the image. We defined three pools: the stage pool, actors pool, and sound pool. Stage and sound pools have only one lane each, while actors pool have one lane for each participant, for example, characters, actors, or objects. Then we have the event component, which describe all the events in the process, like the starting of the process, or, for example, the sending of a message. The main action involved in the process are described with activities. The process is executed following the flow, and there is the sequence flow and the message flow. The gateway component permits to split the flow into different flows. There are two types of gateway, the for gateway and the join gateway. For example, we can note that in the stage pool, the gateway divides the main flow in background, foreground, and midground, while in the actor lane, the gateway divides the flow in movement, sound, and appearance. As previously said, to validate our approach, we designed and implemented a software for the creation of simple animated stories. In the image, we can see the graphical representation of a story within the created software. Then we translate the story in a determined language. Here we can see the translated story. Then we translate the story from intermediate language to an acceptable representation that in our case is the last version of Scratch. As a result of the translation, we have the animated story performed by Scratch platforms. So the user can create a story in the software, and as a result, he obtains the animated stories that can be executed like a video thanks to Scratch and shared online with family and friends. We would like to underline that the user of the software will never see or know anything about the intermediate language or the translation process. First of all, we would like to focus on the source of the approach, that is this created software. Within the software, the user can create characters, objects, and backgrounds, totally personalized, and use them for the creation of a story. In the image, we can see the section of the app where the user can create a new character, specifying the name, the description, the default image, and the different appearance and emotions. Within the software, the user can create or edit a story, working on its scenes. As we can see in this image, the story is presented as a list of scenes, with their backgrounds, images, titles, and durations. Now we would like to briefly describe the scene editor of the app, where the user can create or change the content of the scenes. The main component is the timeline, where the user can define all the actions during the scene with different types of blocks. We have one main line for each character and objects of the scene, and 3 more lines for the narration, the sound effects, and the background music. The movements of the characters and objects are defined with yellow blocks in the first line, the sounds and the dialogues with the blue blocks in the second line, and the appearance and emotion with the red blocks in the third line. In the block details section, the user can insert all the information and details of each block. In this example, we can find the block details of an appearance block where the user can choose the appearance for the selected character. For example, for the sound of dialogue, the block details section, the user can record or upload voices or sound. Then, in the right side of the block details section, we have the scene lines section, where a list of all the dialogues of the scene are presented. And on the left side, we have the background of the scene and the buttons for the player, where the user can see the animated scene performed by Scratch. Now we move on the target of our case study, that is the last version of Scratch. Scratch is an online community and a programming language, where users, especially young people, can program and share interactive media such as games and animations. The code area is the main area of the project editor where the scripts are assembled using coding blocks. In the image, we can see an example of the code area for the cat sprite. When Scratch executed this block, the results start from this image and show the two animation, the cat walking and speaking. Here, we want to briefly describe an example of the translation. We would like to underline again that the user of the software will never see or know anything about the intermediate language or the translation process, and the graph we show below is only a suggested representation of the intermediate language to easily describe it. So we start from the story in the app, and below we can see how it becomes in the intermediate language. For our example, we will focus on the second scene of this story, in particular, from the point of view of the two actors. In the top of the page, we can find the scene editor view of the second scene of the two main characters, while on the bottom of the page, we can find the intermediate language definition of the second scene from the point of view of the same two characters. The initial situation of the scene representing intermediate language with the two components are highlighted here. And in this picture, we can see the initial situation on Scratch where the first character is not shown and the second character is visible in particular position. Moving in this new highlighted section, we can find how the user described this moment of the scene in the editor and the components involved in intermediate language. In this new image, we can see the result of the Scratch player, where we can note that the first character enters in the scene, while the second character changes changed its appearance. Now we move on another section of the editor, and here we can see all the components involved in a determinate language. In this new image, the highlighted moment of the scene is shown in the Scratch player. We can note that the first character is speaking, saying hello, and it has also a different appearance, while the second character had the same position and appearance of before. Between the Scratch images shown during this example, there are all the animation performed by Scratch. Later, we will show a story created in the application and executed in Scratch, so we will see how Scratch performs it. As previously said, we tested the created software within two associations. The first experiment was made with the association Esagramma based in Milan within a special educational path. In this path, young people without autism and intellectual disabilities are involved in the individual session of multimodal interaction within traditional instruments like books or games, but also innovative multimedia contexts like new software or smart boards. We made 4 experiments with 4 different subjects with intellectual disabilities and their psychologists. As we can see in the image, the experiment was made with the support of a computer and an interactive whiteboard. The best settings in terms of using experience turned out to be the ones shown here, so showing the editor on the computer screen and the player of the scene story on the interactive whiteboard. This helped the subjects to be more focused watching the story they are creating animated in a bigger screen. We follow a different approach with the 4 participants, obtaining different results. In this image, we can see the first 2 pages of the reporting document we created, where the psychologists gathered the results and the feedbacks of the experiments. In this document, the psychologist can describe and evaluate the experiment. For example, the evolution of the expressiveness, the goal understanding, the personalization ability, the emotion, and some data about the sentences recorded by the subject. In this table, we can see the result of the first experiment in accordance with the educator's point of view. We will describe only the first 2 experiments to show 2 different ways to use the app. The subject of this first experiment is a 14-year-old boy with Down syndrome. The problems of concentration and communication described by psychologists are evident. In the last session of the multimedia laboratory, he was working on the fox and the hound tale. So the psychologist decided to set up the experiment based on this tale. Together with educators, 30 minutes before the start of the session, we have decided which scenes of the tale we want to represent, and we created the 2 main characters of the story in the application. The experiment was based on the ability of the user to represent the main characters in the scene that he previously studied, to come up with the lines of the dialogues in the scene, record his voice, trying to express emotions of the characters, and to make sounds representing the action in the scene. For example, loud and fast knock on the table for running noise, or slow and soft tap on bongo for soft footsteps noise. The results obtained were satisfying. The use of the application did not bore him, as he felt very happy to see the characters move and speak with his voice. Moreover, despite his concentration problem, he was always very focused and involved, and there was a constant evolution of the vocal expression and emotion expression during the registration of the lines. The protagonist of the second experiment is a 63-year-old woman with Down syndrome. She generally finds hard difficulties in speaking and communicating. The story made during this test is invented by the participant, but the settings were already prepared inside the app as a story template. During the experiment, the user appears active and engaged with a good ability to create and follow the storyline. However, she struggles to express herself, as she needs assistance for speaking and requires a lot of time to tell the story she had decided to perform during the test. But at the end, she was really satisfied with the story she had created. The psychologist underlined that the subject showed significant progress during the experiment, as her vocal participation considerably improved. The second experiment was made with the Association Amici Insieme based in Como, with the support of a computer and a TV screen. In this case, the subjects worked together to be able to evaluate also the importance of using the app in a collaborative learning setting. The experiment was made within a special educational path, where adults with intellectual disabilities are involved for half a day once a week to improve or learn new things like cooking, writing, gardening, and to interact with some children of the neighboring kindergarten. This experiment involved one psychologist, two educators, and three adults with intellectual disabilities, from mild to moderate severe intellectual disabilities. Together with the psychologists and the educators, in the first session, the subject decided to create a story about the life cycle of flowers. And they created the characters, object, backgrounds, the story title, and the scenes list in the software. The second and last session was the main one, where the subject used the application to create an animated full story. In the first session, they were not so happy, and in particular one was very bored. But in the second session, thanks to the using of the app, they were all so enthusiastic, and they all wanted to do more. At the start of this last session, the three subjects chose their roles in the story, and they had to interact with each other through the characters they have chosen. Because each of them represented a single character, this helped them to empathize more with it, have more fun, and gain more stimuli. During this session, the psychologist positively noticed how the subject felt very involved with the process of the story creation and took an active role in it. And this is very important to ensure they are willing to engage in such kind of text, and how much it can help to improve their vocal expression and social interaction. As shown in this table, the satisfaction at the end of the experiment was very high for all the subjects. Two of them showed a high improvement on their vocal expression, and one had constant vocal expression, while two showed a high improvement in the narration quality, and one had a constant narration quality while using the app. Now we will show a small snippet of the story created within the last experiment executed in Scratch.
Mi manca il sole, ho bisogno di calore per crescere. Aiuto io, facciamo il sole. Eccomi, sono un raggio di sole. Non ti preoccupare, ti aiuto io. Sei bella. Grazie per avermi aiutato. Andiamo a fare crescere gli altri semi e poi diventeranno dei bellissimi fiori come me.
Bambini, vi è piaciuta la storia? Il giardino di amici insieme presto sarà ricco di fiori.
In this slide, we would like to summarize the feedback from the psychologists after the two experiments. They say that one of the positive points about the application is that it permits to the user to identify with the characters and the story itself, and to interact with educators and other subjects inside it. These create the opportunity for a cognitive improvement. And this is very important because, unfortunately, this is something that many of them cannot do frequently in their daily lives. The easy and fast way of creating the story permits the user to not get bored and to retain a high level of attention. The possibility to decide all the action during the scene helps the user to observe a continuity in the story and to narrate it in an easy way. Reviewing the entire scene while creating it permits the user to stay in the context of the story and to see or listen to the change in real time as a result of the new blocks added to the scene. The possibility for the user to listen to their voice just recorded while watching the scene evolution, so within a context, helps them and motivates them in improving their vocal expression and the narration of the scenes. Inserting in an easy way new characters, objects, and backgrounds permits the participant to completely personalize the story. It is a very important feature for such users because it is difficult for them to grasp abstract things. So, in conclusion, we started from the problem described in the first slide. Then, for address such gap, we created an intermediate language, and we used it in the creation of a software for storytelling that we tested on the field, and with this, we validate the proposed approach. Now we would like to mention possible future works. Focusing on intermediate language as a future work we could improve the approach using an algorithm for model checking. This should be possible because we define intermediate language with the formal semantic using PyTornet. While we could also add new components to describe new situations. From the application point of view, we could follow the suggestion of the psychologists to improve the blocks inserting and interaction process, and to add new feature to be able to interact with the recorded audios. In conclusion, another interesting future work could be to create a new software or another version of the existing one with different purposes and features, and use the same translation to obtain as a result an executable Scratch file, or to translate the stories from the created software to a new executable representation, for example, to obtain the story in comic format. Thank you so much for listening. Please write me if you have any questions.